lecture series on computer organization and architecture. So we'll discuss module number 3, that is lecture number 21. Contents that was covered in the previous lecture are, that is we have discussed regarding module number 2. So in the previous lecture we have discussed regarding additional instructions such as shift instructions as well as rotate instruction. Under shift instruction we have discussed logical shift operation as well as arithmetic shift operation, whereas in case of rotate operation we have discussed different types of rotate operations like rotate left with carry and without carry, and as well as a rotate operation that is rotate right operation along with carry and without carry. So these things were discussed in the previous lecture. So that completes module number 2. So in this session we'll discuss, or we will start with module number 3. So module number 3 is going to deal with basic input and output organization. So here we are, that is the title of the module 3 is basic input and output organization. So under this module we are going to discuss how I/O devices can be connected, so which are the different mechanisms to access the I/O devices, so as well as even we are going to discuss regarding the speed of data transfer between processor and I/O devices, as well as we are going to discuss regarding interrupts. So these things are discussed in this particular unit. So contents that is covered in this lecture are accessing an I/O devices. Learning outcomes. After this lecture the students will have a better understanding of how to access an I/O devices. So this is the Bloom's taxonomy pyramid level. So today's discussion, or in this session we are going to discuss regarding accessing an I/O devices. So we are discussing two important concepts, that is memory mapped I/O as well as I/O mapped I/O. So as we are going to understand these two concepts, so it is going to fall under the Bloom's taxonomy level 2. So Bloom's taxonomy level 2 is regarding understanding the concepts. So hence today's topic falls under the Bloom's taxonomy level number 2. So first we'll discuss regarding introduction and then we'll move to an accessing of I/O devices. See, one of the main basic feature of a computer is to exchange the information. So it is used to exchange the data with other devices. So one of the basic feature of a computer is its ability to exchange the data with other devices. So that is, one device can communicate with the other devices. So in order, if a device wants to communicate with other devices, normally it requires certain human operators, that is keyboard as well as display screen, in order to process text and graphics. So that is, in short, we can say that a general purpose computer should have the ability to exchange the information with a different devices or wide range of devices depending upon the varying environment. So here a general purpose computer is nothing but which can execute varieties of applications programs. So this computer should have an ability to exchange the information with other devices or any different kind of devices. So here general purpose means it can run different applications. So therefore we say that it can exchange the information with wide range of devices. So here computers are nothing but it is an integral part of an home appliances, manufacturing equipments, transportation systems, banking and point of sale terminals. So normally input to the computer may come from, so which are the sources of the input? So it may be from a sensor, or it might be from a digital camera, or from a microphone, or it can be from a fire alarm. So normally output might be in the form of a sound signal that should be sent to a speaker or digitally coded command to change the speed of the motor, open a valve, or cause a robot to move in a specified manner. So normally computer can take, depending upon the applications, so it can take a input from any kind of an input devices, and after processing it may generate a different kinds of outputs also for the different types of devices that are connected to the computer system. So these are the normal possibilities, like from a sensor switch, digital camera or microphone, or from a fire alarm, a computer can receive an input information. So once the particular information is processed, ultimately it may generate a certain coded means it may be generating certain sound signals. So normally information will be sent to a speaker. So sometimes it is required to control the speed of the motor, so turning on and off the motor, or varying the speed of the motor, and even we can on and off the valve, that is we can turn on and turn off the valve, or it may cause a certain robot to move in a specified manner or in a specified direction. So these are the different possibilities of outputs after processing the program. So now we'll discuss, this is regarding computer, how it should be capable of exchanging the information. So how well it can exchange the information, what are the scenarios in order to exchange the information. So now we'll discuss accessing an IO devices. So we know normal IO devices like keyboard, display devices, monitor, so on. So now a simple arrangement to connect IO device to a computer is to make use of a single bus arrangement. So already we have discussed in module number 1 what is bus. So bus is nothing but it is a group of lines or set of wires that are used to connect the basic functional units of the computer system, normally like a processor, memory, IO devices. So all these things, control unit, arithmetic logic unit, whatever it is, so all these units can be connected with the help of the bus. So bus is nothing but it is a set of lines or a group of lines, or it is a set of wires, so which is capable of carrying certain information. So if these IO devices like processor, memory, IO devices has to communicate, then communication can be possible only with the help of the bus, because the bus is going to carry the information. So it helps us to exchange the information. So thus we are going to make use of a bus in order to connect all these devices, which helps the devices that are connected by using this bus, so that it can, with the help of the bus, they can exchange the information. So that is, the bus enables all the devices connected to it to exchange the information. So normally it will be consisting of 3 sets of line. Bus will be consisting of 3 set of lines, so that is, which is going to carry the 3 different types of information. One is called as an address lines, data lines, as well as control lines. So address lines or the address bus is used to carry the address information. Data lines, it is used to carry the relevant data, and control signal is going to carry lines, or the bus is used to carry the control signals. So here normally we will be connecting different types of IO devices to the processor or to the computer, so such that every IO devices or different IO devices that we are going to connect it to the computer, they should be recognized by the address. So every IO device has to be assigned certain address. So here normally bus, no doubt it is used to connect the different types of devices. So that particular bus, ultimately it is going to carry the information. It helps to exchange the information. So now to that particular computer system we can connect different types of devices, IO devices. So when we are connecting a multiple IO devices, so each of these IO devices has to be recognized. So that can be done by assigning the address for the every IO devices that are connected to the computer system. So therefore each IO device is assigned a unique set of addresses. So if an address is provided, then only that device IO device can be used, or it can be involved in the communication or exchanging of information. So therefore it is essential as well as required to assign the address for each of the IO devices. So now this is the single bus structure, bus architecture. So there are different architectures like single bus architecture and multiple bus architecture. So in case of single bus architecture, we will be using only a single bus. As the name says, we will be using only one bus for communicating the different devices like functional units of a computer like processor, memory, IO device. So here you can check out, we have n number of IO devices connected to the computer system. So all these IO devices are connected with the help of the bus. So here the type of the architecture we are using single bus architecture. So single bus architecture means only one bus is used for connecting the devices. So whenever we are using a single bus architecture, it is going to offer a low cost as well as complexity in connecting the devices is less. That is, it is going to offer flexibility for connecting the IO devices. So in case of multiple bus structure, means the cost is going to increase. So in case of single bus architecture is at a given point of time only one device can communicate with another. So whereas in case of multiple bus architecture, multiple devices can be involved for communication or for exchanging the information. So this is regarding single bus architecture. So now I want to exchange an information between processor and an IO device. So let us check how the information can be exchanged and how exactly we can access an IO device. So that is, in order to access an IO device, the processor has to provide the address of the device on the address lines. So first thing is that if any device needs to be communicated, then that particular IO device address has to be provided. So therefore, to access an IO device, the processor needs to provide the address on the address lines. So the device recognizes the address and responds to the control signals. So once that particular address is once the device is recognizing that address, then it can respond to the control signal. So normally processor will be requesting either for a read operation or a write operation. So read means IO device is used for reading the data, that is we are going to get an information from the IO device. Write operation means the processor is going to send an information to an IO device. So that is called as read or write operation. The most of the time we will be either going with default there will be either a read operation or a write operation, and the requested data are transferred on the data lines. So here the role of the address lines is to carry the address of the IO device, and the role of the data lines is to carry the data information. So the data might be traveling from processor to IO device, or it may be traveling from IO device to processor. So whenever the data is traveling from IO device to processor, it is a read. When a data is transferred from a processor to an IO device, it is write operation. So data lines always carries the data information, but it might be a data from with respect to read or write operation. So now when an IO devices and the memory both are going to share the same address space, then that arrangement is called as a memory mapped IO. So now we have discussed that every IO devices has to be allocated, or they should be assigned with a unique set of addresses. So now instead of the thing is that we are supposed to provide the address for every IO devices, or we have to assign the unique set of addresses for the IO devices. So therefore these addresses can be assigned to the IO devices by sharing the addresses of the memory. So that is in case of memory, every memory location will be for every memory location a unique address will be allocated. So those addresses, few of the addresses of the memory can be assigned as an addresses of the IO devices. So that is, we are going to share the address of the memory as for the IO devices. In order to recognize the IO devices, few of the address of the memory locations can be shared, or it can be used. So that is called as an memory mapped IO. So in case of memory mapped IO, so there is a sharing of an addresses of the memory location to the IO devices. So such concept is called as an memory mapped IO. So that is, when IO devices and the memory both are going to share the same address space, so then such an arrangement is called as an memory mapped IO. So here in case of memory mapped IO, so whichever the instructions that are required in order to access the data from the memory, the same set of instructions can also be used to transfer the data or to access the data from that IO device. So normally whenever we want to access any information from the memory, or if I want to transfer any information to the memory, then most of the time we are going to make use of a copy instruction called as an MOVE. So same MOVE instruction can be used to access the data from the IO device, or in order to transfer the data to an IO device. So this is going to happen in case of memory mapped IO. So that is not only sharing the addresses of the memory location, along with sharing the addresses between the memory device and the memory locations. So same set of instructions that are required to access the data from the memory, the same set of instructions are also used to access the data from an IO device. So here, for example, we have an MOVE instruction. So MOVE data in comma R0. So here R0 is the processor register, whereas data in, it is the register associated with the input device. So data in is nothing but it is the register associated with the input device. So normally input devices will also be having a register associated with it. So in order to speed up, this is done the registers are associated with IO devices, because in order to do with the synchronization of speed of operation, registers are involved in the IO devices. So one of the register that is relevant to the input device is called as an data in, and data out is the name of the register associated with an output device. So here MOV is nothing but normally it is an instruction that is used to access the data from the memory location. So therefore the same memory is the same instruction is, even it is used to access the data from the registers that are associated with the input or output device. So here move data in comma R0. So that is content of an R0 register. So here, data in is the source operand, whereas R0 is the destination. So here we are going to transfer the data from that is, we are going to receive the data from keyboard, or that is from the data in register to an R0 register. So move R0 comma data out means it is going to it is going to transmit the data from an R0 register to an data out. So now let us discuss one more method that is called as an IO mapped IO. So in case of an IO mapped IO, when an IO devices and the memory have different address space. So that is, in case of IO mapped IO, so there is no sharing of the address space. So IO devices and memory, they are going to have a different address space. So then such an arrangement is called as an IO mapped IO. So in case of an IO mapped IO, so we are going to make use of if an IO devices needs to be accessed, then special instructions are used for transferring the data between processor and an IO device. So those instructions are called as an in and out. So whenever we are using an IO mapped IO concept, so if a separate address space is given for an IO devices, then the type of the instructions that are used in order to transfer the data between processor and an IO device are in and out. So here we are not supposed to make use of an MOV instruction in case of IO mapped IO. So that is, we are going to make use of a special in and out instruction to perform IO transfers. So IO devices may have to deal with a fewer address lines. So here it is not required. Suppose in case of an memory mapped IO, so as there is a sharing of the addresses, sharing of address space takes place. So it depends how many number of bits are required in order to provide the address for the memory location. The same number of address bits has to be considered for accessing an IO devices. So but in this case IO mapped IO, so here IO devices, it is may not have means it is not required to deal with the larger address bits. So it will be having a fewer address lines, so less number of address lines will be there. So IO devices may have to deal with a very few address lines compared to memory mapped IO. IO address lines need not be physically separate from memory address lines. So in fact, the address lines may be shared between IO device and memory with a control signal to indicate whether it is an memory address or an IO address. So here IO address lines, we are not supposed to separate it from the memory address lines. So whenever an address lines are going to carry the address of the IO device or a memory, so we can have a separate control signals to indicate whether that address lines is of memory address or it is an address of an IO device. So we can have a control signals to indicate whether it is an address of the memory or it is an address of an IO device. So now let us discuss differences between IO mapped IO as well as memory mapped IO. So in case of memory mapped IO, we know that both memory and IO devices, they are going to share the address space. So that is IO device and memory both are treated as memory. Whereas in case of IO mapped IO devices are treated as an IO devices, whereas memory is treated as a memory. So we have a separate address space for IO devices as well as for memory. So they are treated, both are treated as separate. So whereas in case as we are going to share the address space, so both are treated as memory itself. So in case of memory mapped ports, the information data can be moved to the IO device from any register or vice versa. So if I want to transfer the data between from any that is, if an information needs to be transferred between processor and IO device, it can involve any of the register, any different kind of registers can be used. But in case of an IO mapped, it has to be happen only with an accumulator register. So default register used is an accumulator whenever we are using IO mapped IO. So whatever the data that is transferred, it should be transferred to an accumulator and to an register of an IO device. So whereas in case of memory mapped IO, it can make use of any register. So here as we are going to share the address space, memory address space for both memory as well as IO device, so we cannot utilize full memory address space. So third point says that full memory address space cannot be used solely for addressing memory for interfacing. So I cannot make full address space, full memory space cannot be utilized for memory. So in case of memory mapped IO, because of sharing. So whereas in case of IO mapped IO, so as there is a separate set of address for an IO device, full memory address space can be utilized. So in order to access, coming to and accessing the data, so we can make use of same instructions for accessing memory and IO. Whereas here in case of IO mapped IO, we have to make use of a separate instruction for accessing memory and IO device. So the same instructions in order to access memory and IO device, for example, it might be an MOVE. As we are using a separate, means in case of IO mapped IO, so we are using a separate addresses, separate instructions. So for example, MOVE may be used for accessing a memory, whereas in and out instructions are used for accessing an IO device. So this is the difference between IO mapped IO as well as memory mapped IO. So now let us discuss IO interface for an input device. So this is an input device. If this input device needs to be connected, so what are the interfaces that are required? Let us discuss. So a bus is having a set of lines. It is having a 3 set of lines. That is, one is address lines, data lines as well as control lines. Address lines is going to carry the address of the device, address of the input or output device. Data lines is going to carry the data line is going to carry the data information that either needs to be sent to the particular IO device, or it can access that whatever the data that has been accessed from that particular IO device. So it is ultimately going to carry the data or the information. So here control signals or control lines is going to indicate whether it has to perform read or write operation. So this is an input device, and these are the 3 set of lines. Together we call it as a bus, and in between we have an IO interface. So interface components are address decoder, control circuits, data and status register. So let us discuss each one of this. The figure is going to illustrate the hardware required to connect an IO device to the bus. So suppose if I want to connect any IO device to the bus, it is going to illustrate what are the different hardware components that are required. So the hardware components required are address decoder, control unit, control circuit and data and status register. IO device is connected to the bus using an IO interface circuit. So it is going, if an IO device needs to be connected to the bus, it has to make use of an IO interface circuit, which consists of, as I told, address decoder, control circuit, data and status register. So what is this address decoder? So address decoder, it is going to enable the device to recognize its address when the address appears on the address lines. So no doubt that this address line is going to carry the address of the IO device. So it is that information will be received by this address decoder relevant to that particular IO device. So this address decoder is going to check out, or it is going to identify or recognize whether it is the address of this particular connected IO device. So that is address decoder. It is going to enable the device to recognize its address when the address appears on the address lines. Data register holds the data that is being transferred to or from the processor. So we have a data register here. So data register is going to hold the data, that whatever the data that is check out here, data and status register, it is connected to the data line inside the bus. So whatever the data that is propagating, so it will be stored in the data register. So it might have received the information that is available in the data register, it might have received from the processor, or it may be about to transfer it to the processor. So that is, data register holds the data being transferred to the processor or from the processor. So status register contains information relevant to the operation of the IO device. So it is going to hold the status information. So whether to transfer the data or not to transfer the data, it is completely relevant to the operation side. So data and status register are connected to the data bus and have an unique address. So here we have an IO interface circuit. IO interface circuits coordinates the IO transfer. So conclusion is, we have discussed accessing of an IO devices. So that is, if an information needs to be exchanged, that is if a data needs to be exchanged between processor and an IO devices. So how a data can be exchanged between processor and an IO devices? So there are different methods of connecting the IO device to the processor. So normally we will be, in order to connect the IO device to the processor, we are going to make use of a bus. Ultimately bus is going to carry a relevant information, so that bus helps us to exchange the information between processor and an IO device. So it acts as a connecting path for that is, it is going to connect a processor, memory as well as an IO device. So there are different bus architecture, like single bus architecture and multiple bus architecture. So single bus architecture, it is a low cost flexibility, it is going to offer low cost as well as flexibility in connecting the devices. So once these things are done, our next thing is that here we are going to discuss how IO devices are accessed. So there are different methods. So if an IO device needs to be accessed, so we need to know the address of an IO device. So a unique set of address has to be we have to assign the address to the IO devices. So assigning the address to the IO devices is done in two methods. So that is, one method is called as an memory mapped IO and another method is IO mapped IO. So in case of memory mapped IO, the memory addresses are shared between a memory as well as IO devices, whereas in case of IO mapped IO, separate addresses are given for both memory as well as IO devices. So these are the different concepts whenever we are going to connect any IO device device to the processor. So once the devices are connected, so that is IO devices are connected to the bus, so in between we have an interface circuits which are going to check out, that is they are going to identify the address, as well as they are going to store the information, data information. So this is that is address decoder, data and status register, as well as control circuitry. So this is regarding accessing an IO device. So these concepts are discussed in this lecture. Thank you.